Alright, in this video we're going to go over two questions, hopefully, from the practice test. First question is this linear regression problem about the coffee shops and the crime rate, or number of crimes, I should say. If you need help just entering the data into your calculator and coming up with that equation, I'm not going to go through that here. If you either just search on YouTube for TI-84 linear regression, or if you go to our linear regression homework assignment, you'll see a couple links to videos there that will help you with that. Here I just kind of want to go over more the explanation and these other parts, not just putting the data in and having the calculator spit it out. So when we do put the data in and have the calculator spit it out, I believe we get the equation y equals 415.739 x, so 3, plus 1,433.59. The R value should be 0.963. If your calculator is not showing you the R value, please let me know, or your teacher know. It's just a setting on your calculator we got to change. Part C, how many property crimes do we predict for a county with 15 shops? All we would do there is, because shops is our x variable, we would just plug in 15 for x, and we would get out a prediction of 7,670 shops, and our residual is just the difference between what actually happened in the data set and our prediction. So what actually happened in the data set when there were 15 shops is we had 6,800 property crimes. So my residual is going to be that actual data point, 6800, minus the predicted value, which is roughly 7,670. I don't know why I wrote a 2 there. Which gives me a value of negative 870. I can't write. Okay. Now, questions 1, 2, and 3, which are from actually the next question in your practice test. You had to kind of do this basic information and then these explanations or explaining the meaning of different things in the following one. So what is the meaning of the R value? Well, remember that R has to be between -1 and +1. And the closer you are to either -1 or +1, the stronger the correlation is, the more confident we can feel in our predictions. So in this case, because we're close, 0.963, that's very close to 1, we would say we have a strong positive, because it's close to +1, not -1, correlation. Excuse my handwriting. Number 2, what is the meaning of the slope? Well, we just want to think about that slope as 415.739 over 1. And I'm not going to write this whole thing down. I'm just going to talk about it, because then you don't have to watch me struggle to write neatly. Remember that slope is change in y over change in x. Change in y over change in x. And in this case, my x variable is the number of coffee shops, and the y variable is the number of property crimes. And so we would say, for every additional 1 coffee shop, we expect about 416 or 415.739 additional property crimes within the county. Because we're saying, okay, go over this much, go up this much. Add 1 more coffee shop, add 416.739 property crimes. The y-intercept, remember that y-intercept is a point. It is 0, something. So my y-intercept is 0, 1,433 433.59, which says, okay, even in a county with 0 coffee shops, we still expect to have 1,433.59 property crimes based on our model, which is based on this fairly limited data set. Okay. I think we can fit the next problem in as well. Okay. So we don't know anything about this function h of x other than it has an x-intercept at x equals 5. And now we're saying, well, what if we did all these different transformations to it? How would that change the x-intercept? And so we just look at each transformation. Okay, putting a -2 inside the function, that's going to be a horizontal shift of 2 units to the right. Inside the function, it's horizontal and the opposite. So it looks like -2 would go left, but it actually goes right. So this would be x equals, was 5, 2 to the right, 7. Negative x, that's going to say, okay, we'll just divide all of your x values by -1. Now it is, again, inside the function, so that's a horizontal transformation. It's affecting the x values. And we do the opposite. It looks like multiply by -1, but I should actually divide by -1. Now with 1, of course, multiplying and dividing do the same thing. But if this was a 2 inside, I would need to divide by 2, not multiply by 2. So just take my original x coordinate and multiply it by -1 or divide it by -1. Part C, now the 2 is on the outside. So this is saying this is a vertical stretch by a factor of 2. Take the y coordinate and multiply it by 2, but leave the x coordinate alone. Well, this is the point 5, 0. Leave the x alone, the y coordinate is 0, multiply it by 2, it's still 0. So my x-intercept will actually not change here. It's still just positive 5. Next one, 2 things. They're both inside the function, so it's 2 horizontal transformations. And remember, now that I have 2 horizontal transformations, the order is important. And because it's inside the function, it's horizontal. Because it's inside the function, it has the opposite effect of what we'd expect. And I'm actually going to do it in the opposite order. I'm first going to move left 2, then divide that by 3. So I was at x equals 5. Left 2 means now I'm at x equals 3. Divide that by 3. Now I'm at x equals 1. And there we go.